Thank you very much. Yes, so I'll be the last one today. Thank you for coming and listening. So my name is Jens Falker and I'm from GMN and I'm going to talk about spindles today, how to understand spindles better. And let me start. So first of all, who are we? We are GMN, founded in 1908. So we have more than 100 years experience in high precision bearings, spindles, freewheel clutches and seals or non-contacting seals are our main products. We are still a family-owned business with around 450 employees and all our products are developed and manufactured in Nuremberg, Bayern, Germany and are sold worldwide with service departments and sales departments. Yes, so where do we come from? When we started building spindles, we made spindles with external drives. Very simple mechanical products, but already high precision to manufacture bearings, to manufacture ball bearings. This was the beginning. And then in the second generation, we started integrating motors. So we had internal drives, much higher dynamics in the spindles. And we also started integrating sensors. And when we are talking about the state-of-the-art technology, we are talking about spindles with integrated sensor systems. So it's not only temperature sensors, it's already microcontrollers which interpret sensor signals, who deliver information. That's what we build today and what a spindle is. And when talking about sensors, you can ask, what is it? As I said, temperatures are very common, especially in milling applications. Then we have, for example, acceleration sensors, which can be integrated close to bearings to measure vibrations, to measure process, to catch rattling situations whatsoever. We have unclamping units to detect what condition the tool is in. This is also what I was mentioning, a sensor system. So such an unclamping unit has not only one sensor, it has multiple sensors, it has microelectronics inside, and it already makes an evaluation of these different sensor signals and gives you an information on what condition your tool is in. Another thing we integrate often is displacement sensors to see how the shaft is growing, to make compensations. So the tool center point is always there where you want to have it. So this is how we build spindles today. But how are they connected to the machine? And as you can see here on this slide, this is how it's commonly done. At the end, all the sensor signals integrated into the spindle are brought to the machine cabinet as analog or binary signals. So you have connectors with many pins. And these signals have to be transported to the AD converters, which are in the machine cabinet. So there can be interference, you need tools to mount it, you can make failures there, but this is how we do it. And then everything is connected or brought to the digital world, made available in the field bus, and then can be used in any other systems. Yeah? This is how we do it. And let me give you an example on what this would look like if you would do it at home. This would be as if you mount or need a screwdriver to mount your mouse or your mouse to your computer. This is what we do in the machine tool world. We screw our mouse onto the computer. And we think this is not up to date anymore. We have to find a new way to connect spindles, to make data available, to bring the spindle to the digital world. And let me now explain to you how we want to do this. In our opinion, the next generation of spindle is a digital spindle. So we not only have the sensors in the spindle, we have also information technology in the spindle. So we need systems, or we need an embedded system which does the AD converting within the spindle, interprets the signals, and gives real information to the customer. And at the end, this information has to be transmitted using digital technology, serial interfaces, so it's easy to connect it to the machine. So as I said, we want to have integrated information technology, and we want to utilize a serial interface. And here, in our spindles, we have a system called GMN IDEA4S, which is an embedded system which does exactly what I said. We are digitalizing the analog signals of our sensors, and we are bringing them using IO-Link to the machine cabinet. Yeah? Why do we use IO-Link? IO-Link is coming into the market. It's a growing technology in the machine tool area. Lots of machine tool manufacturers use it for their standard sensors, and it's very easy to implement. It's a standard interface. It has an easy protocol. It's not just hardware which has a standard. It's also the protocol area. The protocol layer is also standardized. So when connecting an IO-Link device to an IO-Link master, everything is done. It's working directly. The communication is ready. You don't need to configure anything. You don't need a tool. You don't need a screwdriver. You just connect this. You install the IODD file, and everything is working finely. And in our opinion, IO-Link will be the new standard in machine tools for standard sensors. And why then not use it also for spindles? So this is how our system looks like. Yeah, it's a multi-sensor which delivers the sensor signals and sensor informations via IO-Link. But what does the system do? Our main topics are: we want to measure the signals, we want to transmit the signals, we want to share the signals in a modern way. We want to identify or bring a possibility to the spindle or to the machine tool to identify a spindle automatically. So the machine tool knows what spindle is mounted into the machine tool. And we want to monitor, we want to understand what the spindle is doing, and to give the machine operator or the machine tool manufacturer an idea if he's doing everything right or not. And we want to make it possible that there's a communication possible between the machine domain and also the spindle domain. So these different domains have to work together, so IoT solutions will be possible. So let me give you an example for what we measure. We measure vibration, so our system has a vibration sensor integrated, 3-axis. We can measure the speed of the spindle, we can measure the unclamping unit, we can measure the temperature, and we can measure, for example, displacement sensors. So all the different sensors which are used widely within spindles will be digitalized and then transmitted to the machine cabinet. We will give you a digital type plate to identify the spindle, and we make it possible to store application information from the machine into the spindle. So the spindle knows in which application have I been used, when have I been used, how long have I been used. And then we monitor what the spindle is doing. What are the operating hours, what's the fingerprint, what's the status of the sensors, what was the maximum temperature, what was the lowest temperature. We will do histogram information, so how long has a spindle been operated at a certain speed, for how long. So we make it possible to understand what the spindle has been doing. And let me give you an example on how this data can look like. So it's not for us about tracing the whole lifetime of a spindle in time data. So which peak was at which time, which temperature was at what time. We want to start interpreting, analyzing the data already on the spindle, and this can be done, for example, with such a histogram. So here we have the speed related to a bearing temperature. Yeah, and you get a diagram like this. And now you see the spindle has been in idle for quite a long time. It's actually quite typical for spindles that they are operated in idle time for a long time. And then you see at which speed ranges has the spindle been operated at which temperature levels. Yeah? Because when you just look at the temperature and you see, okay, the spindle has been operated at 40 degrees for, I don't know, 20 minutes, and you don't know at which speed, this makes a huge difference. yeah, has a spindle 40 degrees at, I don't know, 10% speed, or at 50% speed, or at 100% speed. Yeah? So you have to make a connection between these different signals, and this is something which can be done with the electronic. What's also a very important thing about using IO-Link is that it integrates perfectly into modern IoT infrastructures. Yeah? So when using IO-Link masters, the IO-Link masters, they not just only couple into the field bus, which can be any field bus, it can be Profinet, it can be EtherCAT, whatever you want to use, but it also connects to IoT solutions, and you don't have to bring the data through the PLC. You can directly get the data out of the IO-Link master and use it for remote service, for machine-to-machine communication, for all these IoT solutions. So it's not always necessary to implement such solutions on the PLC level. You can really use IPC technology to use the systems. And this is, for me, a very important thing to stress. When looking at all these different IoT solutions at different machine-to-manufacturers, you will most likely find IPCs which are used for this kind of technology, because you don't want to do everything on PLC level. And this is really a big advantage of IO-Link. Yes, and here is how it looks like when it's integrated into a spindle. You can also see this at our booth. So the electronic is implemented in the back of a spindle. It's a milling spindle here. So many different plugs, but the IO-Link technology also fits in. But what are the benefits now? The system is easy and robust to integrate into the machine. This one's not working anymore. It enables digitalization, which is very important. It's not just about connecting it to the machine, it's also connecting it into IoT infrastructure. You can implement automatic tracking, or you can do asset management with your spindles. So you know which spindle is at which time in which machine. Yeah? How long has it been operated? You know what your spindle has been doing. You get a transparent usage. You have the possibility of fast diagnosis during service, so you better understand what has been done. You are able to explain your customer what he has been doing wrong, so he does it better the next time. And yeah, at the end, this makes new warranty models possible. So using data is something we all have to learn. I think it's still quite new for our business, but the possibilities are huge, and we should utilize them, and we should think together how we can use them. I think we as a spindle manufacturer cannot do it alone. The machine tool manufacturers cannot do it alone. The end users cannot do it alone. We have to work together to find ways to make our machines more efficient, to use our components better. And I think IoT is a good possibility. And at the end, IDEA4S is a solution which enables this. And yeah, this is why we think we are en route to the digital spindle. And we will be happy to discuss this with you in detail. Come to our booth. We are in Hall 3. I think it's F2. And visit us. Have a look. We have a demonstrator with the system. And we are happy to show you. And yeah, now I thank you for your attention. And I hope everyone has a nice evening and will be relaxed for tomorrow. So there's a couple of more days with this fair to go. Okay. Thank you.